All right, can you hear me and see my screen?
Yes, we can. Thank you, Megan. We appreciate you joining us today.
Of course, thanks for having me. Feel free to interrupt me as I'm going through this presentation. It can be more of a conversation, or I can just talk your guys' ears off as we go through this. So I'm very passionate about software engineering, so I'm really excited to tell you guys about that.
Great.
So I'll start off by telling you a little bit about myself. As she just said, I'm Megan Sorensen. My background is in computer engineering. I graduated from Ohio Northern University in 2016, and I'm currently working on a master's in computer science through Georgia Tech, on top of working as a software engineer during the day. I'm currently with CAE USA, which is a defense contractor that provides training and operational support solutions to global defense and security customers. We were recently acquired. Before that, I worked for L3 Harris, and I still work in the same exact position. Nothing has changed other than the company I work with. So I've been there for about 2.5 years. And before that, I was also a software engineer at Cardinal Health in Dublin, Ohio. And the project that I'm currently working on, it's called Mission Planning and Debrief. Essentially, the higher level version of this project is we're helping mission commanders plan for the future missions faster and better than they have before, which is really interesting. And I can give you guys more of an overview on that project in a little bit. But before I start getting into that, I wanted to talk about what is a software engineer. And so I thought it might be interesting to pull the different definitions of software versus engineering and kind of put them together for you guys. So when I'm talking about what is a software engineer, we're all on the same page. And so software, the official definition, it's a collection of codes, documents, and triggers that do a specific job and fill a specific requirement. Software is everywhere. We're using it right now as you're listening to me talk about it. And then also engineering is the development of products using best practices, principles, and methods. So if you could imagine putting those two together, software is everywhere, but the way that we bring in engineering to this is the way that it's implemented. We have lots of different practices, principles, and methods that we want to ensure the code that we write is the best. It can be reused. It won't break. If we find things with it, we fix it. That's kind of the path that a software engineer will take. The official definition of software engineering is it's a branch of engineering that deals with the development of software products, operates within a set of principles, best practices, and methods. So kind of like what I was just saying, putting those two together, it's the way that you develop in the software is very different when you have an engineering background versus just jumping in and working on software. I also threw in the definition of from IEEE for what they think a software engineer is, but essentially it covers the same ground as the other definition that I talked about. So I wanted to kind of go through a typical week for myself. As Janet was saying earlier, they do daily stand-ups. We also do something very similar. Our team currently is working from home with the pandemic, but our goal is to go back to base. We're at Wright-Patterson Air Force Base in Dayton, Ohio. But what's really nice about this daily stand-up call is we have all of the developers go through what they worked on the previous day, what they're working on today, and then any blockers or any issues that they're running into. So this is a really good way to start the day. If a developer is stuck on a coding issue, they can't figure out where something should go, or they just need to talk to another developer and pair program to try to figure out an issue, we can start the day off with this and kind of get them running. The rest of my day will probably be working on the software ticket I assign myself. I'll go through what those tickets are in the next slide, but essentially most of my day is going to be hands to keyboard coding, which I love, and you definitely need to like coding to want to be a software engineer, because that's what most of my week is going to be. I would say I'm in meetings for about 4 hours, and then 36 is going to be actually just writing out code. There are some meetings where you meet with customers throughout the week, but most of my time will be actually implementing the code, which I really prefer to do than sitting in meetings with customers trying to figure out what exact requirements they want us to implement. Oh, went the wrong way. So I was just talking about a ticket. And so the way that my team implements and kind of figures out what we're working on is we use, it's called Agile Methodology. I'm sure you guys have heard of it. And if not, I would recommend looking it up just because it's a really nice way to figure out what everyone's working on and keep everyone accountable for the work that they're doing. So if you look at the right picture in the top right, where the customer is pointing at the laptop saying, okay, I want this feature implemented. We take that and we create a post-it note, which we have an actual board online, but this is just a nice picture that kind of shows how the charts work. And we put whatever they say into a ticket. And so if you can see on the left picture, we have this sprint goal and the sprint board where we have all these tickets. Each ticket is going to be either a bug or a new feature request. When I'm talking about a bug, that would mean that something in the application is broken or it's not working as it should. And so we need to fix it. Let's say they click on a link and it takes you somewhere else instead of where you actually wanted it to go. That would be considered a bug. Whereas a new feature is they could say, hey, I want this whole new view created where the user can change their password. And so that would be an example of a new feature. And essentially what the developer would do is at the beginning of a sprint, our sprints last 2 weeks, but it's kind of up to whatever team, whatever they feel is best for the team. They would grab a ticket and say, okay, I want to do this ticket. And you would drag it into the doing column. And that way everyone can see that in this example, Fred is currently working on that specific ticket. So we know during our stand-ups, okay, that's what he's working on. And then we can kind of see the progress. So once he's done completing his ticket, he'll move it in done and so on. And that's kind of like the cycle of our software development team. So to get more specific into what the ticket pipeline is, I just talked about you would assign yourself a ticket. I did write out one example of a ticket, what that would look like to the developer. So this example is to add a new view where the user can draw a route on a map. Every single ticket would also have a description. And if the developer is confused on what the ticket is supposed to say or anything like that, they could talk to the tech lead or the task order lead is what we call our program managers over on base. But essentially it should have everything that they need to know to kind of jump in and start working on that ticket. After that, they would create a branch off of master. So if you look in this diagram on the right, all the blue dots are going to be the branch of master, which essentially is the repository where all of the application is sitting. And so this allows for the team to work on multiple things at the same time. And so someone else could be working on a little feature where they just create a branch off of one of the nodes or commits, as we call them, where they could be working on fixing a little bug on another view. And then I could grab this ticket and be working on this big feature of actually implementing this route on a map. And so the goal of this is to allow the team to work on a bunch of tickets simultaneously. And then we would end up merging them back into master at the end of this, just to kind of keep the pipeline moving so no one's waiting on something else to get done. Once you complete your ticket, the way that it does get merged back in is we have the team creating a pull request. Essentially, the goal of this is just so that you can get another set of eyes on the ticket. That way, in case I accidentally broke some other part of the application with my creating of this route ticket, I accidentally changed code that impacted something else, I would have someone else check that before merging it in. And the goal of that is so that they could catch things like that. And so I'm just not blindly merging stuff into the application. And it also is a really good practice. Every single developer team that I've been on has done a very similar structure to get code merged in. And it's just a really good coding practice to have. And then after you create your pull request, before grabbing another ticket, at least for our team, we like the team members to go through and approve other pull requests and give feedback, just to kind of keep that life cycle moving and keep the team moving forward to get all the tickets done for that specific sprint. And I believe this is just another view of the same thing that I was just explaining. The goal is to figure out exactly what you need to do before starting the ticket, create the branch, implement the changes, update any tests. We also have 100% line coverage for all of our application. And so that also helps ensure that no new bugs get added into the application as we're going through the process of adding new tickets. That example of me accidentally changing code that impacts another part of the application would get caught by these tests, and the test would break, which would also not let them merge my ticket into master, which is just another nice catch, so that we don't have new developers coming in and trying to implement code that would accidentally break other code, because that does happen a lot with a lot of developer teams, but this is at least one way to catch it before anything bad gets merged. So most of my day is going to be sitting behind a desk. I say sit or stand because I have a nice stand-up desk, which is currently at work. So I'm sitting right now, but essentially most of my day is just hands behind a keyboard, typing away, or pair programming and helping out the rest of the team figuring out their issues. We do not really have any on calls, but I have been on teams in the past where the application is working with a hospital. And so if they had issues with the application, it was specifically a pharmacy hospital where they were working with keeping track of their medications in a cabinet. And so on that team, we did have to be on call one night a week. But on the team that I'm currently on, the only hours that we have to be working is from 9 to 3 for our core hours, and then plus or minus 2 hours to make it an 8-hour day. And then no weekend work, at least with this job. But I have been on other development teams that have, if we have a really big feature coming up or a deadline, you might have to work some extra hours here or there to just ensure that everything's tested correctly, just because you don't want to make a release with bad code in there. And so you have to be really passionate, and it won't feel like it's a lot of extra work here or there. But most weeks I'm only working 40 hours a week, which is really nice. So talking about education or experience that helped me secure my career position, it definitely helped that I had a bachelor's of science in computer engineering. This definitely helped me speed right through to the interview process. But being a part of a software engineer, there are a lot of boot camps that people can do. So it's not required to have a degree to be a software engineer. It definitely helps though. If I was looking at a couple different resumes when hiring a new software engineer, I would probably pick someone with a degree over someone who's just completed a boot camp. But I would probably just interview both of them and then see their skill set from the interview. So that wouldn't stop them from getting an interview, but some places it would probably pick someone else over them. And then of course, experience in the field, that's always a plus. And then internships going along with that. If they're just starting out right after college, I would be looking for someone who has experience either in an internship or just working on development projects at night outside of work or school. There are so many different programming languages out there. So just seeing that they're motivated to want to learn different languages. The nice thing about being a software developer is once you learn one programming language, you can kind of jump back and forth through different ones. There's just some small things that change, but essentially the overarching structure of code does not change too much from language to language, which is really nice. And then I also like to call out extracurricular activities. I always like to look at what people are doing in their spare time. When hiring, it's not, I'm not going to talk to you if you don't have any extracurricular activities, but that is just something that I look at when reviewing resumes. And then for this slide, I wanted to talk about some different qualifications that I look for specifically. I know I kind of just touched on that a little bit. But other than having some type of degree, when I say or something similar, that would count as a boot camp. There are ones that are, I think, 14 weeks long that students can do instead of going to college. That I actually work with a few folks who did that instead of college, and they're actually much smarter than I am. So it would just depend on what you want to do. It's not going to stop you from getting a degree or anything, or a job, whether you did a boot camp or a college degree. And then I would definitely say you have to be determined and care about what work you add. Some of these applications impact the real world. So for instance, the one that I'm currently working on, we're helping pilots plan missions for the war of the future. And so you really have to care about what you're putting in there, because you don't want to accidentally add a bug here or there that would stop them from planning a mission specifically and impact that, which there are lives at stake when it comes to that. And so you have to just be really careful and really determined to make sure that what you're putting out is the best. And then you also have to love learning new technologies. So as Janet touched on earlier, IT and technologies everywhere, new programming languages, they're always changing. And so we've actually rewritten our application a couple different times in different programming languages. And so you just have to be really eager to jump in and learn these new programming languages and just be flexible in what you're doing. And then also great communication skills. As I said earlier, you might be pair programming. You might have to teach someone a little bit about the code, or you might just need to help them out and figure out what their issues are. And so being able to work on tickets by yourself or in a pair is definitely critical to being a really good software engineer. I'm also calling out database experience just because every single team that I've been on has had a big database where you have to change a lot of things. So just having a high level database experience would just be good. It wouldn't have to be in a specific database. We do use MySQL database on my team, but there's the skill set would change or would transfer really easily for any database. So that wouldn't have to be a specific database program. And then also a few different languages, just being able to transfer those skill set. That's one thing I really like. I've been able to work in a lot of different programming languages and just always learn new tasks and everything. And so just being ready to jump in and learn a lot would make you a really good software engineer. And then having different experience doing projects outside of work, that is definitely critical when at least starting the job. It's not a lot of outside of work per se, but at least being able to jump in and do tutorials and kind of get your feet wet with learning the different programming languages is definitely crucial. And then I also wrote bonus experience working on an agile team. I would say now it's very popular to work on an agile team. Every single team that I've been on has been agile, where when I say that, I mean working in the 2-week sprints and having the ticket process, seeing exactly what you need to do and implementing it. That is very popular. And I would say almost every single team out there probably has some sort of ticketing software that they use. We specifically use Jira, Jira, but there is a free version called Trello that's out there right now that we have used in the past. If you just want to get a feel for what that looks like. And that you could actually use for any other tasks too, whether it's outside of being a software engineer and you just, you have a project on the house that you want to work on, you can create tickets for that and say, okay, I need to paint the house and do all this thing. And you can just throw those into tickets and just keep track of it. So I think it just helps the team stay organized, and you could really apply this anywhere. I obviously use it more for software engineering, but I've worked with projects outside of it that I've used that ticketing system, and it helps move everything along. So for what skills do I value most in an employee? I know this is a bunch of words here, but I would say probably the couple ones that stick out to me is definitely determination. A lot of the tickets that people grab are going to be new to them. They're not going to know right away, how do I fix this? And they're not going to know right away, is this the right way to fix it if they think of different solutions. And so you just have to be really determined to kind of jump in and figure out what's going on. And then I also mentioned communication earlier. Speed is really good too. Caveat for that is if you're working on a ticket and it's taking you a little bit too long, this is something that I've definitely struggled with as a developer, is when to ask for help. And so that's something that it's a tough balance to figure out. Okay, I've been working on this for a little bit longer than I think I should. Let's ask for help and get some feedback on if I'm going in the right direction or if I need to start over and think of a new path. And then specifically for my job, I know I kind of touched on this a little bit earlier, but how my specific job relates to the company's success. Specifically with my team, we've pretty much digitized the way that that pilots plan missions in the Air Force. And so originally it would take pilots 8 to 12 hours to go through planning an entire mission. The reason for this is because they would get this air tasking order, which is essentially just this really long file that would have all the information they would need to know to plan this mission, and they would write it out on a whiteboard. And that could take them up to 8 to 12 hours just to write that part out, because those could be 20 pages long and it would just take a really long time. And this is one of the reasons why I love technology, because we were able to take this process, digitize it, and within a matter of minutes, we're able to plan out the entire mission for them so that they could focus more on the tactical planning of the mission. And then on top of this, we also work with some machine learning engineers that have created intelligent agents to be able to think through the plan and actually update the plan generated to make it more robust and help the pilots plan more tactically. And so that's just one example of at least the project that I work on, which makes me really excited because we can speed up so many things using technology. And there's so many different projects that we could use technology to help speed up the process. And so I just am really excited about this specific project. I also implement a lot of customer feedback and new features as their request, but essentially our main project that I'm currently working on is digitizing mission planning for the Air Force, which I think is pretty cool. And then I kind of talked about this a little bit earlier, but I would say that probably the top 3 things when someone is interested in becoming a software engineer that you need to know is to have really good communication skills, because part of this is also working with the customer. They will tell you some type of requirement. You will take that and you'll have to translate that into code. And you'll also have to work with different developers. So it's kind of having that good balance of communication from a business perspective, but also you want that technical background as well to be able to actually translate it to a ticket or some type of development task that you have to work on. And then also flexibility. So I wanted to talk about, you need to be really flexible. There's been instances when you're working on a specific ticket, the customer will say, okay, implement this way. And you'll go through the entire process and you'll complete that. And then you'll show them and they'll say, actually, I think it'll look better this way. Can you do that? And so you just have to be really flexible to be able to say, okay, that's totally fine. Let me just scrap all the work that I did. And it's a really good learning experience. You've still learned what you just did, and you are losing the code that you wrote, but just to be able to be flexible and learn a new way of doing things and just be okay with jumping back and forth on the fly, because that's definitely happened to me a few times. And I'm sure a lot of other developers are in the same boat when it comes to that. And then the ability to solve problems. So I said more than half of your time as a software developer or engineer is going to be problem solving. So you would have different bug tickets or different features, and they're not going to say, okay, this is exactly how you do it. You're going to have to figure out for yourself, okay, how do I implement this the best way for the code, the best coding practices, and also thinking about the future of the application. How can we make it future proof? If we're thinking about adding some other feature similar to it later on, is there a better way that I can write this now so that we can reuse some of this code later on? And so it's kind of a big balance, figuring out what's the best way to solve this problem, whether it's a bug or a new feature or whatever ticket that you get. You just have to be ready to solve a problem, which definitely makes work interesting, but I really enjoy that part. And another slide for why I love it. As I was just talking about, new challenges every day. Some of them are going to be really tough and you're going to need help. But also what I really like is trying to figure it out on my own. You get to solve a lot of different problems. You get to learn a lot of new technologies. Just in this past role that I've been in for the last 2.5 years, I've written code in at least 4 or 5 different programming languages, and a couple of them I didn't know from the beginning. So I was able to just jump in, do some tutorials, learn really fast, and get the ball rolling, and also get a couple things to add to my resume, which was really nice. You definitely are always busy. There's never not tickets coming through the pipeline from the customer. And I also really like it because you can see results really fast. So since our application is web-based, you can pull up and you can see right away the changes that you're doing, which I think is really nice. And you get a quick satisfaction just seeing, okay, I just implemented this whole thing. Let's see it. Okay, this is what I did and this is awesome. And then also there's always a need for software engineers. Software is huge nowadays. And so you get to always know in the back of your head that there'll always be positions, very flexible. And then you also get to be really creative and give a lot of input. So I'm able to, if I see something in the code or some implementation that I'm not a fan of, I'm able to talk to the team and say, hey, let's change this. Let's do it this way. And then they can always say no and tell me why, and we can talk it out. Or they can say, oh, that's a really good idea, Megan. Let's do it this way. And it just kind of gives everyone a lot of input, which I really enjoy too. At the end of this, I just wanted to call out some helpful tutorials for those who do not know a lot about computer science and want to jump right in. I would recommend this course through, I think it's through Harvard, called CS50. I think it's on EDX, but the link I posted will take you there too. But essentially, it just kind of gives you an overview of computer science and will give you the basics for being a good software engineer. I think it's an 11-week long class, but it's very beneficial and one of the top known college courses that is in the computer science realm. I also threw in a couple other tutorials. One of them is to build a website using HTML and CSS. That one's really fun to do. You just jump right in and you can just see a website right away and you can change different things. And that's very high level. And then the Git tutorial, those branches that I was talking about earlier, that'll hit on that and kind of give you the pipeline for what you want to do when you are committing code. And pretty much every software engineer, that is a skill you will need to know or at least learn pretty quickly when you become one. I also threw in a MySQL tutorial and a Python tutorial for database, or Python's just another language that is very popular and very easy to learn, in my opinion, and those would probably be really good places to start. But if you guys have any other questions, just let me know and I can always send you more specific tutorials. And that's it. So I just wanted to say thank you guys so much for listening to my talk on software engineering. I threw my email in there, so if you guys have any other questions, feel free to reach out after this if you think of anything. But I'm very passionate about software engineering and I love it, and I encourage everyone to at least dabble in it and see if it's something that you want to pursue.
Thank you, Megan. It was great information. I thank you for the tutorials, the website links. I'm sure that a lot of students will be going there and playing on it. And your job sounds very rewarding, and it's going to have some great impact, significant impact for the military. So thank you for all the work you're doing with them.
Oh, of course.
Yeah, and we got a couple of questions that came through. The first one is, did you know you wanted to be a software engineer in high school? If not, what led you to this career path?
So in high school, I knew that I wanted to be an engineer just because I always dabbled in computers. I didn't know if I wanted to be a math teacher or a software engineer. So I actually started college out being, my major was engineering education through Ohio Northern, which is where you get a degree as an engineer and a degree as a math teacher in the 4 years. And you kind of get best of both worlds. I had an internship after my freshman year where I learned how to code and created a website from scratch and really found my passion specifically for software engineering. So then after that, I changed majors to computer engineering and went through that. But in high school, I started just learning how to code in my spare time. We didn't really have any classes specifically. Our closest engineering class was probably more of a shop class than an engineering coding class, which I did take, but it was really more in my spare time. I learned how to create a website and kind of fell in love with that.
Okay, great. I know that university really appreciates your shout out too.
Yes.
I didn't know they had that program.
Yeah, I believe they're the only undergraduate school right now with engineering education as a major. So I would check it out. It's really cool.
Yeah, that is really interesting. And I know you talked about a lot of different programs. If a student's focusing on one program initially start off with, which one do you think is most beneficial?
So I would probably start out with building a website from using HTML and CSS. That would probably be the fastest for them to kind of see something in front of themselves. That or the Python tutorial would probably be my two tutorials to start out with. The other ones is more learning experience and seeing different projects come together. But if you want to see something right away, that's probably your best bet.
Okay,
Is one of
great.
those two tutorials.
Well, thank you. It's very helpful. Are there any other questions? There was one more about which language do you use the most? Thank you. I think you pretty much covered that in your last answer. Sorry.
Oh, no worries.
Yeah. All right. Well, if there's no other questions, we definitely appreciate your time today. We thank everybody for coming today, and we hope everybody has a wonderful and safe Thanksgiving. Next week, we will be discussing IT security and web development. So you all have a great day and a nice week. Thank you all.
Thank you. Have a good one.
Thank you.